Welcome to Vision Plus and welcome back to this Senior for Mathematics. Today we are going to see how we can find the equation of the circle when we are given the coordinates of the center and 1 point on the circle. We are given the center and 1 point lying on the circumference of the circle. So example 1 says, find the equation of the circle given the coordinates center and 1 point on the circumference. So for part A we are given the center, which is 0, 0, and then the point on the circumference. We just say the point on the circumference is what? Is 2 and negative 1. We can sketch this circle in this manner. Just draw the circle, and then the center is 0, 0. So you come and mark here, just put the center there, and say the center has coordinates 0 and 0. And after putting the center there, then you come and put these points. Remember, this is just a point lying on the circle, on the circumference. So you can put it anywhere you want, because we are not locating the circle on the Cartesian plane. So you can put the point anywhere you want, because the circle can be rotated. So assuming this point is here, this is the point, which is 2 and negative 1. So the center is 0, 0, which is there, and the point on the circumference on a circle is 2 and 1. Now, how can we find the equation of the circle? Remember, I said that any circle is defined by the center and the radius. Now we have the coordinates of the center. What we do not have is the radius. Once you know the center and the radius, you can write the equation of the circle. That means we know that any distance from the center of the circle to any point on the circumference is what we are calling radius. So we are going to find radius r, and then we use the coordinate of the center to find the equation. Now, it has happened here that the radius r is the distance between 2 points, that is, the point of the center and the point on the circumference. And from your coordinate geometry in Senior 2, you know how to find the length between 2 points, or the distance between 2 points. So for us to find r, the formula for finding the length between any 2 points is given by length is given by the square root of x2 minus x1 plus bracket squared plus y2 minus y1 bracket squared. Please go back and revise your coordinate geometry, because we are applying it here. So if this is the formula, now what is x2, what is x1, what is x2, I mean what is y2, what is y1? These are the coordinates. Remember, the first point of the coordinate is always x, and the second one is y. So this is x, this is y, this is x, this is y, but we are calling them x1, x2. Now the first at the center, this is x, this is y. On the circumference, this is x, this is y. But to distinguish between them, to differentiate them, you can choose to say, this is my x1, this is my y1, this is my x2, this is my y2. Okay? Or even you could say, this is my x2, this is my y2. Then you come and say, this is my x1, this is my y1, and you get the same answers. I have not said that this is x1, this is x2. No. The given coordinate has x and y. Please, you go and revise that. So after naming them in this manner, x1, y1, x2, y2, then you come and substitute. Now the length, which has which has become r in this case, becomes the square root of, and then we substitute. The formula says x2 minus x1. So you come x2 is 2 minus x1 is 0, close the bracket, is squared, plus y2 first, y2 is negative 1, minus of the formula y1 is 0, and then you square. Now from here, you press your calculator, subtract and square, subtract and square. So this one gives me 4 here, 2 minus 0 squared is 4, negative 1 minus 0 squared is positive 1. So I'm finding root of 5 here as radius. Therefore, the radius r is root 5 units. That is how you find the radius. This is how you find the radius. So after getting the radius, now you can write the equation of the circle, and you know that we need the center, which is 0, 0, and the radius of the circle, which is the length between the two given points. That is the center and the point on the circumference. Here you have the liberty either to write it in the factorized form or in the expanded form. There is no limitation to that. There is no limitation at all. So the center is 0, 0. So let me use the factorized form, which is given by x minus a squared plus y minus b squared equals to r squared. Then I substitute x minus a. Remember the center is 0, 0. So this is a, this is b. So minus a, which is 0 squared, plus y minus b, which is also 0 squared, equals to r, which is root of 5, but we are squaring it. So from here, x minus 0 is x. So here we have x squared plus y squared equals to root 5 squared is 5. And therefore, this is the answer. This is the equation. This is the equation of the circle, which is centered at 0, 0 and is passing through that one point on the circumference. So this is the answer for part A. We are going to approach part B in the same way. So you can even try it out so that you see where your mistakes will be, and then you correct them accordingly. So for part B, we are given the center C. The center is given as 2, 1, and the point on the circumference where it is passing through is given as negative 3 and 2. So just to guide you, it is important that you draw a rough estimate of the circle, just to guide you as a beginner. So I'm going to draw, this is my circle, just something like that. You may use a ruler, you may use a protractor, or you can sketch it. So this is the center with coordinates 2 and 1. And then there is a point in the circumference which is negative 3 and 2. You put that point anywhere you want. Please, anywhere you want. Anywhere you want. In this case, I want it here. That means this is the point on the circumference, negative 3 and 2. Now, for us to write the equation of any circle, we need the coordinates of the center, which we have, and the radius. But now we don't have the radius. What do? We need to find the distance from the center up to the point on the circumference. That gives us now the radius. Okay? So we need to find the distance between the center and the point on the circumference, and that gives us the radius. So the formula for any length of the line, now in this case it is now the radius r, is given by square root of x2 minus x1 squared plus y2 minus y1 squared. And then you go and name your coordinates the way you want. You can call this is x, this is y, this is x, this is y. But to distinguish them, you know that this is the point of the center, this is the point of the circumference. You can attach You can call this one x1, y1, x2, y2. Or you can say this is x1, y1, x2, y2. You get the same answers. So for me to be consistent, always I'm going to call the coordinates of the center as 1, 1. So this is going to be my x1, y1, x2, y2. Then we come here and substitute. This gives us here now the square root of x2. x2 is negative 3. Please take the signs of the numbers minus of the formula. Okay, x1 is 2 squared plus y2 is 2 minus of the formula y1 is 1, and then we square. Then you press the calculator. This gives us here what is negative 3 minus negative 3 minus negative 3 minus 2 squared. I'm getting positive 25. Use the calculator, put them in the bracket, plus 2 minus 1, 2 minus 1 squared, still 1 plus 1. So 25 plus 1 gives us a root of 26 units. So this is now the radius. Therefore, radius is root of 26 units. After getting the radius and you have the coordinates of the center, then you can find the equation. These are the coordinates of the center A and B. So I'm going to write it again in the factorized form because it is lighter, and we do not have to find C again in the as we do in the expanded form. So and here there is no limitation. So now therefore from x minus a, which is the factorized form, y minus b squared equals to r squared. Substitute for a, b and r. A is 2. So we have to x minus 2. Don't forget to square plus y minus b. B is 1. Squared equals to r. R is root of 26. Save your time here. Root of 26 squared. You can skip some steps. In mathematics, marks are awarded for the shortest root and for the correct root. You have to be fast and accurate. So here we have to find r squared, which is the same as root of 26 squared. What gives us here 26? We have skipped one step already, which is this one. And our answer is correct. So this is the equation of that circle with that center and that point on the circumference. I'm trying to be very slow because this is example 1. But in example 2, I will be faster because we shall have the foundation. So to conclude with, in the same sense, part C we are given center as 4 and 1. 4 and 1. Please copy your information accurately from the question to avoid errors. And then the point on the circumference, which I'm just calling point on the circumference, there is 0 and negative 3. What is the first step? Sketch the circle to guide you so that you can visualize the radius. I'm going to sketch my circle in that manner. Even if it is not a perfect circle, it is a circle, you know that. And then at the center here, I have the coordinates of the center, 4 and 1. And then anywhere on the circumference or on the circle, put this point anywhere you want, anywhere you like. But for me, in this case, I like it up here. And it has coordinates 0 and negative 3. After sketching that, we have the center, so we don't have the radius. And the radius is the distance from any point on the circumference up to the center of the circle. So this is my radius r. So I know the formula that the radius r is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. This is the formula for the length between any 2 points. and in this case our length is r. That's why I'm putting there radius. So after writing the formula, then you come and name them. I've said that this is always x, y, x, y. But to differentiate them, you can call the ones at the center x1, y1, x2, y2 on the circumference. Then you come and substitute. This here would give us now the square root of x2. x2 is 0 minus x1. x1 is 4 squared plus y2. y2 is negative 3 minus y1. y1 is 1. And then we square it. Then we proceed and we say this gives us now square root of what is 0 minus 4 is negative 4. Negative 4 squared is positive 16 plus negative 3 minus 1 is negative 4. Negative 4 squared is again positive 16. 16 plus 16 is root of 32. So after getting the radius as root of 32, therefore radius root of 32 units, then you have the radius and the coordinates of the center, which are A and B. So you can use the coordinates of the center and the radius to find the equation. And that is what we did. We looked at how we can find the equation when we have the center and the radius. So I'm going to use the factorized form again, which is x minus a squared plus y minus b squared equals to r squared. On substituting now, we have x minus what is a. A is the first coordinate of the center, which is 4 squared plus y minus b. B is the second coordinate of the center, which is 1 squared equals to r. R is root of 32. But we are looking for r squared, so we square root of 32. We square root of 32, it gives you 32. Please, we are using the coordinates of the center here, which is a and b. We do not use the coordinates on the circumference. The coordinates on the circumference only guide us to find the radius. After getting the radius, they are not important to us. So this now becomes the equation. So this is the equation of the circle that we are looking for. So you can leave this as your answer. So this is the solution to example 1, which is the foundation for finding the equation of the circle when we have the center and 1 point on the circumference.